Welcome to qnawire.
Okay, so we are being asked to find the vertical and horizontal asymptote of f of x. So um, we are going to first try to find if there is a vertical asymptote. So vertical asymptote occurs when the denominator is equal to 0, so 1 minus e to the x equals 0. So you add e to the x, so you get 1 equals e to the x. And if you plug in 0, or you could just, okay, so there's two ways to do it. You can take the natural log on both sides, and then just eliminates the e, and natural log of 1 is 0. So this will be 0 is equal to x. So we have a vertical asymptote at x equals 0. Now to find the horizontal asymptote, we take the limit as x goes to infinity. So we first find it at infinity. So that would be e to the x over 1 minus e to the x. You can do direct substitution. I mean, not direct substitution. You can pull out a factor of e to the x. So limit as x goes to infinity. You pull out e to the x, so this will be 1. And then you do e to the x out here again, so this will be 1 over e to the x minus 1. And then you cancel e to the x. And then if you take the limit as x goes to infinity, this will become, so this will be 1 over, and then 1 over infinity is 0, so 0 minus 1, so this will be negative 1. Now let's take the limit as x goes to negative infinity. So this will be e to the x over 1 minus e to the x. For this one, you have to apply, let's see. You can apply a sort of same principle, but you can think of the graph. So remember that the graph of e to the x looks like this. So it rises, looks something like this. So it goes off to infinity, but as it goes to negative infinity, it approaches 0. So whenever you see a limit at x goes to negative infinity of e to the x, you can assume that e to the x goes to 0. So this can be 0 over 1 minus 0, and this will equal 0. So that's why it's really important to have an idea of the shape of some of the important functions, the shape of the graph, and it really helps you with finding the limit when it comes to things like this to make it more intuitive. So we have two horizontal asymptotes. We have one at y equals negative y equals 0, and sorry, and y equals negative 1. Now, to find where the function is increasing or decreasing, we apply the first derivative test. So we find the first derivative, so you apply the quotient rule, and you get e to the x over 1 minus e to the x squared. And we set this equal to 0. And you're supposed to find the critical numbers of this function, but since e to the x cannot equal 0, we have to look for places where this function is undefined. So when the bottom is equal to 0, so 1 minus e to the x squared equals 0. So you get rid of the square root by hitting square on both sides, so this will become 1 over 1 equals e to the x, and this occurs at x equals 0. And then you do a sign chart evaluation. So add 0, the sign of f prime. So when it's less than 0, it is actually positive, and if it's greater than 0, it's positive as well. So this function is always increasing, so increasing from negative infinity to infinity. No local min or max. So no local min or max. To find the function's concavity, we take the second derivative. So this comes out to be e to the x plus e to the 2x over 1 minus e to the x cubed. So this equals 0. The top cannot equal 0, which is impossible. So we look at where the denominator equals 0, so it's 1 minus e to the x cubed. Get rid of the cube by taking the cube root, so it'll be 1 equals e to the x again, and now be x equals 0. So again, we evaluated around 0. So we create a sign chart. Sorry, that is not very straight. 0. So if you plug in values less than 0 into f double prime, you get positive numbers, and if you plug in greater than 0, you get negative numbers, so it's concave up and down. And we have an inflection point at x equals 0. So now we have enough information to draw the graph of our function. So we have the function, first of all. As it goes to negative infinity, it approaches 0. So it will come from 0. And then it is concave up, so it's going to increase. And then it'll go off to infinity because x equals 0 is the vertical asymptote. And then it says it is concave down, but it is also increasing. So the only way it can be concave down and increasing, it has to look like this. And we have a horizontal asymptote at y equals -1, and that makes sense. So it will come up like this. And that is the graph of f of x.